The North American Aviation P-51 Mustang is an American long-range, single-seat fighter and fighter bomber used during World War II and the Korean War, among other conflicts. The Mustang was designed in April 1940 by a team headed by James H. Kindleberger of North American Aviation, NAA, in response to a requirement of the British Purchasing Commission. The Purchasing Commission approached North American Aviation to build Curtiss P-40 fighters under license for the Royal Air Force, RAF. Rather than build an old design from another company, North American Aviation proposed the design and production of a more modern fighter. The prototype NA-73X airframe was rolled out on September 9, 1940, 102 days after the contract was signed, and first flew on 26 October. The Mustang was designed to use the Allison V1710 engine, which had limited high-altitude performance in its earlier variants. The aircraft was first flown operationally by the RAF as a tactical reconnaissance aircraft and fighter bomber, Mustang Mki. Replacing the Allison with a Rolls-Royce Merlin resulted in the P-51B/C, Mustang Mk3, model and transformed the aircraft's performance at altitudes above 15,000 feet, 4,600 meters, without sacrificing range, allowing it to compete with the Luftwaffe's fighters. The definitive version, the P-51D, was powered by the Packard V1657, a license-built version of the two-speed, two-stage supercharged Merlin 66, and was armed with 6.50 caliber, 12.7 mm, and /M2 Browning machine guns. From late 1943, P-51Bs and P-51Cs, supplemented by P-51Ds from mid-1944, were used by the USAAF's 8th Air Force to escort bombers in raids over Germany, while the RAF's 2nd Tactical Air Force and the USAAF's 9th Air Force used the Merlin-powered Mustangs as fighter bombers, roles in which the Mustang helped ensure Allied air superiority in 1944. The P-51 was also used by Allied air forces in the North African, Mediterranean, Italian, and Pacific theaters. During World War II, Mustang pilots claimed to have destroyed 4,950 enemy aircraft. At the start of the Korean War, the Mustang, by then redesignated F-51, was the main fighter of the United States until jet fighters, including North American's F-86, took over this role. The Mustang then became a specialized fighter bomber. Despite the advent of jet fighters, the Mustang remained in service with some air forces until the early 1980s. After the Korean War, Mustangs became popular civilian warbirds and air racing aircraft. In 1938, the British government established a purchasing commission in the United States, headed by Sir Henry Self. Self was given overall responsibility for RAF production, research and development, and also served with Sir Wilfrid Freeman, the Air Member for Development and Production. Self also sat on the British Air Council Subcommittee on Supply or Supply Committee, and one of his tasks was to organize the manufacturing and supply of American fighter aircraft for the RAF. At the time, the choice was very limited, as no U.S. aircraft then in production or flying met European standards, with only the Curtiss P-40 Tomahawk coming close. The Curtiss-Wright plant was running at capacity, so P-40s were in short supply. North American Aviation, NAA, was already supplying its T-6 Texan, known in British service as the Harvard trainer to the RAF, but was otherwise underused. President Dutch Kindleberger approached Self to sell a new medium bomber, the North American B-25 Mitchell. Instead, Self asked if NA could manufacture P-40s under license from Curtiss. Kindleberger said NA could have a better aircraft with the same Allison V1710 engine in the air sooner than establishing a production line for the P-40. John Atwood of North American spent much time from January to April 1940 at the British Purchasing Commission's offices in New York discussing the British specifications of the proposed aircraft with British engineers. The discussions consisted of freehand conceptual drawings of an aircraft with the British officials. Sir Henry Self was concerned that North American had not ever designed a fighter, insisting they obtain the drawings and study the Curtiss XB-46 experimental aircraft and the wind tunnel test results for the P-40, before presenting them with detailed design drawings based on the agreed concept. North American purchased the drawings and data from Curtiss for £56,000, verification needed, confirming the purchase with the Purchasing Commission. The Purchasing Commission approved the resulting detailed design drawings, signing the commencement of the Mustang project on May 4, 1940, firmly ordering 320 on May 29, 1940. Prior to this, North American only had a draft letter for an order of 320 aircraft. Curtiss engineers accused North American of plagiarism. The British Purchasing Commission stipulated armament of 4.303 in, 7.7 mm, machine guns, as used on the Tomahawk, a unit cost of no more than $40,000, and delivery of the first production aircraft by January 1941. In March 1940, 320 aircraft were ordered by Freeman, who had become the executive head of the Ministry of Aircraft Production, MAP, and the contract was promulgated on 24 April. The NA-73X, which was designed by a team led by lead engineer Edgar Schmude, followed the best conventional practice of the era, designed for ease of mass manufacturing. The design included several new features. One was a wing designed using laminar flow airfoils, which were developed cooperatively by North American Aviation and the National Advisory Committee for Aeronautics, NACA. These airfoils generated low drag at high speeds. During the development of the NA-73X, a wind tunnel test of two wings, one using NACA 5-digit airfoils and the other using the new NACA 45-100 airfoils, was performed in the University of Washington Kirsten Wind Tunnel. The results of this test showed the superiority of the wing designed with the NACA 45-100 airfoils. The other feature was a new cooling arrangement positioned aft, single-ducted water and oil radiators assembly, that reduced the fuselage drag and effects on the wing. Later, after much development, they discovered that the cooling assembly could take advantage of the Meredith effect, in which heated air exited the radiator with a slight amount of jet thrust. Because NA lacked a suitable wind tunnel to test this feature, it used the Galsat 3.0 meters, 10 feet, wind tunnel at the California Institute of Technology. This led to some controversy over whether the Mustang's cooling system aerodynamics were developed by NA's engineer Edgar Schmude or by Curtiss, as NA had purchased the complete set of P-40 and P-46 wind tunnel data and flight test reports. The NA-73X was also one of the first aircraft to have a fuselage lofted mathematically using conic sections. This resulted in smooth, low-drag surfaces. To aid production, the airframe was divided into 5 main sections: forward, center, rear fuselage, and 2 wing halves, all of which were fitted with wiring and piping before being joined. The prototype NA-73X was rolled out in September 1940, just 102 days after the order had been placed. It first flew on October 26, 1940, 149 days into the contract, an uncommonly short development period, even during the war. 26. With test pilot Vance Breeze at the controls, the prototype handled well and accommodated an impressive fuel load. The aircraft's 3-section, semi-monocoque fuselage was constructed entirely of aluminum to save weight. It was armed with 4.30 caliber, 7.62 mm, and /M2 Browning machine guns in the wings and 2.50 caliber, 12.7 mm, and /M2 Browning machine guns mounted under the engine and firing through the propeller arc using gun synchronizing gear. While the USAAF could block any sales it considered detrimental to the interests of the U.S., the NA-73 was considered to be a special case because it had been designed at the behest of the British. In September 1940, a further 300 NA-73s were ordered by the MAP. 17. To ensure uninterrupted delivery, Colonel Oliver P. Eccles arranged with the Anglo-French Purchasing Commission to deliver the aircraft and gave 2 examples, 41-038 and 41-039, to the USAAF for evaluation. The Allison engine in the Mustang I had a single-stage supercharger that caused power to drop off rapidly above 15,000 feet, 4,600 meters. This made it unsuitable for use at the altitudes where combat was taking place in Europe. Allison's attempts at developing a high-altitude engine were underfunded, but produced the V1710-45, which featured a variable speed auxiliary supercharger, and developed 1,150 horsepower, 860 kilowatts, at 22,400 feet, 6,800 meters. In November 1941, NA studied the possibility of using it, but fitting its excessive length in the Mustang would require extensive airframe modifications and cause long production delays. In May 1942, following positive reports from the RAF on the Mustang I's performance below 15,000 feet, Ronald Harker, a test pilot for Rolls-Royce, suggested fitting a Merlin-61, as fitted to the Spitfire Mk9. The Merlin-61 had a two-speed, two-stage intercooled supercharger, designed by Stanley Hooker of Rolls-Royce. Both the Merlin-61 and V-1710-39 were capable of about 1,570 horsepower, 1,170 kilowatts, war emergency power at relatively low altitude, but the Merlin developed 1,390 horsepower, 1,040 kilowatts, at 23,500 feet, 7,200 meters, versus the Allison's 1,150 horsepower, 860 kilowatts, at 11,800 feet, 3,600 meters, delivering an increase in top speed from 390 miles per hour, 340 knots, 630 kilometers per hour, at 15,000 feet, 4,600 meters, to an estimated 440 miles per hour, 380 knots, 710 kilometers per hour, at 28,100 feet, 8,600 meters. Initial flights of what was known to Rolls-Royce as the Mustang MKX were completed at Rolls-Royce's airfield at Hucknall in October 1942. At the same time, the possibility of combining the P-51 airframe with a U.S. license-built Packard version of the Merlin engine was being explored on the other side of the Atlantic. In July 1942, a contract was let for two prototypes, briefly designated XP-78, but soon to become the XP-51B. Based on the Packard V1653 duplicating the Merlin-61's performance, NA estimated for the XP-78 a top speed of 445 miles per hour, 387 knots, 716 kilometers per hour, at 28,000 feet, 8,500 meters, and a service ceiling of 42,000 feet, 13,000 meters. The first flight of the XP-51B took place in November 1942, but the USAAF was so interested in the possibility that an initial contract for 400 aircraft was placed 3 months beforehand in August. 36. The conversion led to production of the P-51B beginning at North American's Inglewood, California, plant in June 1943, and P-51 started to become available to the 8th and 9th Air Forces in the winter of 1943 to 1944. Conversion to the two-stage supercharged Merlin-61, over 350 pounds, 160 kilograms, heavier than the single-stage Allison, driving a four-bladed Hamilton standard propeller, required moving the wing slightly forward to correct the aircraft's center of gravity. After the USAAF, in July 1943, directed fighter aircraft manufacturers to maximize internal fuel capacity, they calculated the P-51B's center of gravity to be forward enough to include an additional 85 US gal, 320 liters, 71 amp gal fuel tank in the fuselage behind the pilot, greatly increasing the aircraft's range over that of the earlier P-51A. NA incorporated the tank in the production of the P-51B-10 and supplied kits to retrofit it to all existing P-51Bs.